In today's video, we are going to explore hydrocarbons, focusing particularly on a group known as alkanes. But before diving into alkanes, it's important to understand that this entire area of chemistry is known as organic chemistry, which is the branch of science dealing with compounds that contain carbon. Carbon is an incredibly versatile and useful element when it comes to forming large molecules. This is because each carbon atom is capable of forming 4 strong covalent bonds. Most often, these bonds occur either with other carbon atoms or with hydrogen atoms, which results in a vast variety of organic structures. Now, many molecules consist only of carbon and hydrogen atoms. We refer to all such compounds collectively as hydrocarbons. A hydrocarbon is defined as any compound that is made only from carbon and hydrogen atoms. For example, a molecule such as butane is a hydrocarbon because it contains nothing but carbon and hydrogen. However, a similar-looking molecule like butanol is not a hydrocarbon because it contains an additional oxygen atom. The simplest type of hydrocarbons belong to a family called the alkanes. These are saturated hydrocarbons and form the most basic homologous series in organic chemistry. You are required to know the first 4 alkanes in the series. The smallest alkane is methane, which consists of just 1 carbon atom bonded to 4 hydrogen atoms. It has the molecular formula CH4, with carbon forming 4 bonds as always. Next comes ethane, with 2 carbon atoms and 6 hydrogen atoms, making its formula C2H6. Then we have propane, which has the formula C3H8, followed by butane, which is C4H. If you observe these formulas carefully, you'll notice a pattern. With each step up the series, the molecule gains 1 carbon atom and 2 hydrogen atoms. This consistent pattern helps us classify these molecules into a homologous series, a group of organic compounds that share similar chemical properties and a common structure, differing by a CH2 unit from one member to the next. Because of this uniform structure, we can write a general formula for alkanes. H22. This formula may seem complex at first glance, but it simply means that for any alkane, if N is the number of carbon atoms, then the number of hydrogen atoms will be 2 times N plus 2. For example, if we want to find the formula of propane, which has 3 carbon atoms, we substitute N with 3. That gives us 2 times 3 plus 2, which equals 8 hydrogens. So the molecular formula is C3H8. You only need to memorize the first 4 alkanes, but you might be asked to apply this general formula to find the molecular formula of larger alkanes. For example, if you're asked to determine the molecular formula of octane, which contains 8 carbon atoms, then N equals 8. So you calculate 2 times 8 plus 2, giving us 18 hydrogen atoms, resulting in the formula CH8. Now, before we conclude, it's important to highlight a key feature of alkanes. They are saturated compounds. This means that all the carbon-carbon bonds in alkanes are single covalent bonds, with no double or triple bonds present. Each carbon atom is fully saturated with hydrogen atoms. If, for example, we were to take a molecule like propane and replace one of its single bonds with a double bond, each of the carbon atoms involved would have to give up a hydrogen atom to maintain the bonding rules. The resulting molecule would no longer be an alkane. Instead, it would belong to a new family called alkenes, which contain carbon-carbon double bonds, but more on that when we study cracking in an upcoming video. In the next video, we will continue with alkanes and take a closer look at their properties and learn how to write equations for their combustion reactions, which is a key part of their chemistry. That wraps up this lesson on hydrocarbons and alkanes. If you found it helpful, feel free to share it with your friends and stay tuned for the next part.
See you next time.